All right, let's roll. Geometric sequences. So again, we're getting back to sequences in the middle of a chapter. And so this time we talked about arithmetic sequences. And when you talk about arithmetic sequences, remember there is a common difference. So for example, the first term was a 1, and the next term is a 4, and it's arithmetic. 1, 4, what's next? 7, and then 10, and there's a common difference, right? So arithmetic sequence, there is a common difference. With a geometric sequence, there is not a common difference. There's something else, and so that's what we need to talk about. So grab your green. Geometric sequence is when each successive term is found by multiplying the previous term by a common, not difference, a common ratio. Got it? Ratio. Can you say that? Come on. Ratio, yes. Come on. There's Spanish in here. You have to roll if you're Spanish, right? You got to be a roller if you're Spanish. A common ratio. All right. So not a common difference, but a common ratio. So let's take a look at our example here. And let me go a little lower, and that'll be fine. A little lower yet. Beautiful. All right, so we got the sequence 5, 15, 45, 135. Immediately you should understand, hey, this is not an arithmetic sequence. There is no common difference. Therefore, you'd have to ask, is it in fact a geometric sequence? Well, if it is, it's going to have a common ratio. Now, just remember a few things. The first term is a sub 1, right? The second term is a sub 2. The third term is a sub 3. The fourth term is a sub 5, or a sub 4. That was good. The fourth term is a sub 5. No, I don't think so. All right, so et cetera, 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 et cetera. And so a sub 2, the second term, and this thing must have auto-corrected, and I didn't catch. These should all be lowercase. The second term will equal the first term, the previous term, times r, our common ratio, right? So you get this little equation. The second term equals the first term times r. So how could you find r? Take the second term and divide it by the first. Or take the 10th term and divide it by the... Take the 10th, divide it by the 9th. Take the 50th, divide it by the 49th. Take the 4th, divide it by the 3rd, etc., etc. You can figure out that common difference. So, what is our second term? It's a 15, right? What is our first term? It's a 5. And therefore, our common ratio is the ever-popular 3. And what happens when you multiply 5 by 3? You get. And when you multiply 15 by 3, you get. And when you multiply 45 by 3, you get. And therefore, the fifth term has got to be, who knows, right? What is that? 405? Yeah, I think so. 405. My brain is hurting. All right, doesn't want to do that. So the common ratio is important. And how can you find it? It's real simple. Take the third term, divide it by the second. You'll get it. Take the second term, divide it by the first. You'll get it. Take the fifth term, divide it by the fourth. You'll get it. Generally, you want to use the second and first if they told you the second and first because the numbers are smaller. But you could get it either way, right? Don't you agree 45 divided by 15 is 3? And even 135 divided by 45, that's also 3. It's always 3. This is a geometric sequence. So there's a common ratio instead of a common difference. All right, geometric sequence. Notice the graph of the geometric sequence. It's off to the right here. And this is actually an exponential growth. The 1 is the first term. So this is the term. And the right-hand side is the value. So you got the term first term, second term, third term, etc. And so you can see I have 1, 5, right? The first term's value is a 5, and the second term's value is a 15, right? And if I had a 3, I'd have to go all the way up to 45. And if I had a 4, I'd have to go all the way up to 135. So this is called an exponential growth, actually, the curve of it, and that's what it looks like. So our arithmetic sequences are lines. Our geometric sequences are curves. If you were investing money, Josh, you would love to have your money look like this. Because with money, usually this is time, and this is still value. And therefore, in a little bit of time, your money is shooting up. All right, that's if you would have bought Google stock way back when Google came out. If you would have bought Apple stock way back when Apple came out, you might look like that. Doesn't look like that anymore, but that's the idea. All right, enough of that. Let's take a look at recursive and explicit formulas. Remember, our arithmetic sequences had a recursive formula and an explicit formula, and so do our geometric sequences. So your R goes out front in the recursive formula, and then the A here, I keep having capital letters. I guess it's your book, I don't know. And this is an n minus 1. A sub n minus 1. Okay, so let me interpret. This is simply what we just figured out. Let's suppose this is the second term. How do you get the second term? Take the R value and multiply it times second minus 1 is 1, the first term, right? If n was a 7, how do you get the seventh term? Multiply the sixth term, 7 minus 1, right, times the R. So all this is saying is, how do you get the next term? Multiply the previous term by R. That's all you have to do for a geometric sequence. Multiply the previous term by R, and you'll get the next term. What's the limitation to a recursive formula? You've got to know R, and you've got to know the previous term. For example, if the 20th term, Austin, is 10, and the value of R is negative 3, so what did I say, though? What term was 10? 20th. So if the 20th term is 10 and R is negative 3, what's the 21st term? Austin? Don't know. All right. So again, what the recursive formula does for us is it allows us to find a term if we know the previous term. If I know the 10th term, if I know the 20th term is 10, if I multiply it times R, negative 3, I'll get the 21st term. 10 times negative 3 is negative 30. The 21st term must be negative 30. If I know the 7th term, I can multiply it by R and get the 8th term. If I know the 50th term, I can multiply it times R and get the 51st term. If I know the 100th term, I can multiply it times R and get the 101st term. If I know the 87th term, I can multiply it times R and get the 88th term. But I got to know the previous term to use the recursive formula. That's the restrictedness of it. I can get a term, but I got to know the previous term to be able to get the next one. That's the recursive formula. R times the previous term. Here, I'm going to do that in red. This is simply the previous term. Of course, R is the common ratio. So multiply the common ratio times the previous term, and you'll get the next term. And A sub n is the next term. Next team, that's good. Here, I want it red anyhow, so it doesn't matter. Okay. So how do you get the next term? Multiply the previous term times R. If you know the previous term. Well, what if you don't? Hence the explicit formula. Explicit. And just to confuse students, because mathematicians love to confuse students, we could also call it the general term formula, because we want to confuse you. Not a big deal. There are two different names. Okay, so how does the explicit formula work? A sub n, any term. If we know the first term and we know r, we can get any term. So we're going to multiply times r, but now the r's exponent is n minus 1. N minus 1. Remember, the explicit formula allows you to figure out any term. In this case, we have to know the first. We have to know the value of r, and then we can figure out any term. The value there is great in that instead of counting all the way up to a term, we can figure it out specifically. I'll mention that again as we do a couple examples. All right, so two different formulas, and you got to keep them straight. The recursive formula, what does it allow you to do? It allows you to find a term if you know the previous term and the value of r. What does the explicit formula allow you to do? It allows you to find any term if you know the first term and the value of r. Okay, let's go through and do some sequences. All right, list the first 5 terms of each geometric sequence. So, we're given an explicit formula for A. A sub n equals 4 times 2 to the n minus 1. So let me interpret for you. The 4 was the first term, A sub 1. The r was the 2. Because again, this is the explicit form. So the first term was a 4, and r is a 2. Therefore, if I'm going to start writing out a sub 1, I know is a 4, right? Let's come off to the right here. Let's figure out a sub 2. How do we do it? We do the 4 of the formula times the 2 of the formula. What's the value of n? No, what's the value of n? What's the value of n? 2. Look, we're doing a sub n. A sub 2. The n is a 2. So this is going to be 2 minus 1. Okay, we can all do 2 minus 1. We end up with 4 times 2 to the first, and therefore the second term is an 8. Now, if you know what's going on and you know the value of r, you could actually just keep going and just multiply each one by 2. But again, if you were going to use the formula, you would keep going. But at this point, do you see how the next value is going to be 16? Anybody know how I got 16? Right? If the common ratio is 2, I can take the previous term and multiply it by 2. Here, I'll do it with the formula. So if I wanted the third term, right, isn't that what I just did? I need to do the first term, the 4, times 2 to the n. This time n is 3, n minus 1. So now the third term is going to be 4 times 2 squared. 2 squared is 4. 4 times 4 is 16. Hence, the third term is 16. But again, if I know r is 2, I know the fourth term is 2 times 16 is 32. And if I know r is 2, the fifth term is, Connor, 64. Okay? And there are the first 5 terms. First 5 terms. So here's if you want to do it the math way, right? And using the r equals 2, I just multiply the previous term by r, and I'll do it the intuitive way, which most would prefer the intuitive way. So let's look at this second sequence. First term is 6, right? Here, I don't want ace of 1. So if I'm going to list the first 5 terms, I have a 6. I can use the explicit formula if I want. I'll have to make it myself. Or I could simply say the second term is... Okay, so there's a lot of disconnect right now, and a lot of you guys are in the dark, and none of you are asking questions, and you need to start asking questions so I can begin to clear up your darkness wherever your area is. All right, there are 2 ways of looking at these problems right now when it says give me the first 5 terms. I can take the explicit formula right here and use it to find the second term, the third term, put 3 in for n, the fourth term, put 4 in for n, the fifth term, put 5 in for n. Okay, I can do it that way. Or I can use my knowledge of a geometric sequence, use my knowledge of a geometric sequence, and I can understand that the next, let me go back. I can understand that the next term always comes from the previous one times r. Nice knowledge to have. Pretty simplistic. Multiply r times the previous term, you get the next term. Now let's go back to where we were. I have a term, 6. I knew it was the first term because it told me the first term is 6. But I also know the value of r because it told me. If the first term is 6 and r is 7, the next term has to be 6 times 7 is 42. Again, I can write the explicit formula and go the math way. But if I know the previous term and I know r, I can just figure it out. All right, you're probably going to need your calculator for the third term. Take your calculator out because it gets pretty big pretty quick. Who's got it punched out? Connor, what do you got? 294. Anybody agree? Everybody catch on? We're multiplying 42 times 7. And to get the next term, we're going to multiply 294 times 7, right? So what's that one? 2058, and that's the fourth one. We need one more, right? And again, it's a geometric sequence. So we're going to multiply that times a 7. Previous one times 7. And the last one is 14,406. Anybody concur? Okay. Don't make it harder than it is if you understand for a geometric sequence, the next term is always the previous times r. So again, you can do it the math way, or you can do it the intuitive way. The intuitive way is a whole lot easier if that's the capability. Now here on number 4, that's a little different problem. In number 4, they're asking for the 7th term. So we want to find the 7th term. It gave us the explicit formula. Instead of figuring out, okay, by the way, looking at this, what is the value of the first term? Say it if you know it. 8. See, what you want to start realizing is this form, right? Ace of 1 is the multiplier of the base to its exponent. So ace of 1 is 8. What's the value of r in this one? What's the value of r? See where the 3 is in the r's place? 3 is in the r's place. R is 3. So the first term is 8. The second term is 24. 8 times 3 is 24. The third term would be 24 times 3, or whatever that becomes. Now, you could go all the way through, all the way up to the 7th term, or you can do it the math way. The 7th term is when the n is a 7. 8 times 3 to the 7 minus 1. Now, everybody's going to need their calculator out because you need to know how to work your calculator. So one more step here before we punch it in. So the 7th term is 8 times 3 to the 6th, correct? All right, stay with me. Don't go ahead because I got to make sure you're hitting the right button. Your calculator is going to have a couple different ways to do an exponent. You guys agree, order of operations, we've got to do this part next, right? Yep. So you punch in the base to 3. You're going to have probably one of these 3 buttons. You might have an X to the Y button. So you would punch in 3, X to the Y button, and then the 6. You might have a Y to the X button, at which case you would punch in 3, Y to the X, and then 6. Or you might have a caret button, which looks like that. A lot of you have the caret button, at which case you would punch in 3, the caret button, then the 6. All right? So find which button you have. I have Y to the X on my old calculator here. And that part should get you 729. Did you get 729? You got to make sure you get 729. Everybody punch in your calculator. 729, did you find your right button? Who did not get 729? Kaylin, what's your calculator? Let's take a look. Hold it up for us. Okay. So did you find either of those 3 buttons? The X to the Y to the X, or the caret button? That's what you got to look for. Anybody have a calculator like hers? Can you show her, Pamela? No. Anybody have a calculator like Kaylin? Where's the button?
It's like it's this one right here under the replay button. The X with the square.
Got it? Who else needs to figure out their button? Pamela, hold up your calculator. Anybody have a calculator? You probably have the caret button. That's an older calculator. Anybody else have that calculator? Right there, Y to the X. You have Y to the X. Anybody else? Everybody else got it? Okay, so then now that you have your 729, multiply it times the 8. And therefore the 7th term is 5,832. Agreed? $5,832. Okay, the last example is a little bit abstract, and so I got to be careful here to help you guys to know what's going on in this first example, or this last example B. This format, does it look like this? Yes or no? Is it the same pattern? No. What is it the pattern of? The explicit, or the recursive formula, right? Do you see that? See the look? So this one is the recursive formula. So if I want the 7th term, I'd have to either write out all 7 terms, or I'd have to get to the explicit formula. All right. So with the recursive formula, this is R. Do you agree? All right. So R is -3. That we know. Let's figure out the first term. You know what, I'm going to pause for a second, guys, because I don't know that I like this example, and I don't know if I got it from the book or if this is one that I made up. because without them telling us the first term, we have to assume that this is a 1. And I don't like that. Because the first term doesn't always necessarily have to equal R. Okay, just don't even worry about B. Just don't even fool with it. It's not worth it, and I don't want to confuse you. And I think it's not a good question anyhow. If they would have told us the value of the first term, then we'd be in business. What do I have? 3 minutes? All right, let's make a quick modification. Let's add a sub 1 equals, let's say 2. Okay? A sub 1 equals 2. All right, we need to find the 7th term. I can now use my explicit formula. I know it's the first term times, I'm going to put in the negative 3 for my R to the n minus 1. But I had to know that the R was the negative 3. Okay, now we're putting in 7s, right? 7 goes there. What is the first term? A 2. What is R? A negative 3. What is n? A 7 minus 1. So again, understand, I made the explicit formula because I knew the value of R and I knew the value of A of 1. Okay? I made it. I took the value of R from what they gave me originally, and I took A sub 1 from what they gave me originally. Therefore, I was able to make my own explicit formula. I made that from R and from A of 1. Finish this off. Oops, that should be blue. You got to do the exponent first. What's a negative 3 to the 6th power? No. What's a negative 3 to the 6th power? Here, this is a negative 3 to the 6th power. Is it positive or negative? It's positive. So again, my advice is parentheses, negative 3, close parentheses, hit that button, whichever one you have, and then 6th power. It ends up positive, right? Negative 3 to the 6th power is positive. Oh, so that value is a 20, that can't be. It's a 729 times 2. Final answer, 1,458. 1,458. Hey, real quick, before you guys shut down. It's kind of neat with geometric sequences when R is negative. The first term is a positive 2. What's the second term going to be if R is negative 3? Negative 6, right? Negative 3 times 2 is negative 6. What's the next term? Stop. What's the next term? Positive what? What's a negative 6 times a negative 3? Positive 18. Will the next term be positive or negative? And the next term will be, all right, that's what I wanted you guys to realize. All right, you're dismissed. We'll pick up here tomorrow.